So students, we are talking about analog transmission, and in the introductory part, I told you about 3 different techniques, in fact 4 different techniques that are available for the digital to analog conversion. So the first one is ASK, then we've got FSK, PSK, and then CAM, QAM. Students, before we go into the discussion of amplitude shift keying in detail, there were a couple of concepts that I told you about. The first one was the concept of bit rate versus baud rate, and then there was a concept of the carrier signal. Students, we have to do a couple of examples, and then we'll jump into the detailed discussion of the amplitude shift keying, our first method or our first technique of converting our digital signal into our digital data into analog signal. Students, in this case, what we have is an analog signal which can carry 4 bits per signal element. The question is, if you've got 1000 signal elements which we are sending per second, then we need to find the bit rate. Students, the value of R is 4 bits per signal element. The value of S in this particular case, which is our signal rate, is 1000. And we need to find the value of N, which is our bit rate. What I've told you is your S is equal to N divided by R. In this particular case, this is going to be N will be equal to your signal rate multiplied by your ratio R, and your bit rate will be 1000 multiplied by 4, which is equal to 4000 bits per second. Students, second example को देखेंगे. In this case, we have a bit rate of 8000 bits per minute. So your N is 8000 bits per minute. You have a baud rate which is 1000 bauds, and we need to find the value of L. We need to find the value of L, and we also need to find the value of how many data elements are carried by each signal. So we need to find R as well. Now, starting off, we know that our S is equal to N divided by R, and from this we can deduce that your R is equal to N divided by S, and so your R is equal to 8 bits. 8000 divided by 1000 is 8 bits per baud. Students, the units of data rate is bits, and you have bauds here. So we are going to be sending 8 bits per baud. So our the ratio R is 8. Now we need to find out how many signal elements do we need. Students, we know that R is equal to log to the base 2 of capital L, where L is the different signal elements. So in this case, your L is going to be 2 raised to the power R, and we already have the value of R, which is 2 raised to the power 8, and so the total number of our elements is 256. So you have found your L and you have found your R.